Forget Mauna Loa. Forget every volcano you've seen rising above clouds, lava, and ash. Earth's most mysterious volcanic giant is not standing in front of us, it is buried beneath the Pacific Ocean. This is Tamu Massif, a volcanic mountain so wide that for decades, scientists did not recognize it as one structure. It was too large to look like a volcano. Above water, volcanoes are easy to understand. They have peaks, craters, smoke, and slopes. But Tamu Massif hides its shape across hundreds of kilometers of seafloor. The reason it stayed hidden is simple and terrifying. The ocean erased its identity. 2 kilometers of water covered the summit, and the rest vanished into black pressure and silence. Tamu Massif doesn't rise like a jagged mountain. It spreads. Its slopes are so gentle that if you stood on them, you might not even know you were standing on a volcano. Only modern sonar mapping began to reveal the truth. Ships crossed the Pacific, firing sound into the abyss, waiting for echoes to return from a buried world. When the echoes were assembled, the picture was shocking. A rounded volcanic mass stretching across an area comparable to a small country, hidden in plain sight beneath the waves. To understand the scale, imagine placing the British Isles over the Pacific seafloor. Tamu Massif's footprint would swallow that familiar map into a single volcanic shadow. Its story begins around 145 million years ago, when the Pacific seafloor was being torn open by moving tectonic plates during the late Jurassic and early Cretaceous world. At a place where spreading ridges met, magma found a weakness. The crust fractured, the mantle melted, and basalt began flooding upward into the deep ocean. This was not a small eruption from a mountain peak. It was a planetary-scale outpouring of basalt, building layer after layer across the dark ocean floor. For years, scientists debated whether Tamu Massif was one enormous shield volcano or a massive volcanic system built along spreading ridges. That debate made it even more fascinating. The early idea was dramatic. Maybe lava flowed outward from one central source. But newer magnetic evidence suggested a more complex origin, not one simple vent, but focused ridge volcanism. That is what makes Tamu Massif powerful as a story. It was not just a discovery, it was a correction. Science looked again, and the giant changed shape. At these depths, the water pressure is crushing. Lava does not explode into the sky. It chills, hardens, and spreads in silence, forming black volcanic plains. On land, volcanoes announce themselves with ash clouds and earthquakes. In the abyss, a volcanic world can rise, harden, and disappear without a single human witness. Today, Tamu Massif is considered ancient and inactive. Its great eruptions are long over, but its rocks still preserve the memory of a time when Earth's crust pulsed with impossible force. The deeper question is not only what Tamu Massif is, it is how much of Earth we still do not understand. The ocean covers most of our planet and hides its largest scars. We have mapped distant worlds with stunning precision, yet huge areas of our own seafloor remain unresolved. The Pacific is not empty, it is unfinished knowledge. Tamu Massif reminds us that Earth still contains frontiers, not in space, not on another planet, but under the waves, where darkness protects mountains larger than nations. If something this massive could remain misunderstood for so long, what else is waiting beneath the ocean floor? Unknown volcanoes, lost plateaus, buried ridges, entire worlds without sunlight. Tamu Massif is not just a volcano, it is a warning. The largest stories on Earth may not rise above us. Some are still hidden below,